Welcome to the next quest. In this quest, you're going to implement critical hits. Now, this means you're going to need to capture some attributes and determine whether the hit is critical. Now, you can use the critical hit chance for this and use critical hit resistance to reduce that effective chance. And if you get a critical hit, double the damage and add a critical hit bonus for critical hit damage. Now, if you want a bonus challenge, you can add a critical hit resistance coefficient. And we have a curve table for our damage calculation coefficients. So if you feel so inclined, make that a parameter, and then you can scale your critical hit resistance by a coefficient that changes based on level. And you're going to have to decide whether these attributes are captured on the source or the target. So there are a few steps to this quest, but I think you're capable of handling it. So go ahead and pause the video and conquer this quest now. All right, I'm back in my ExecCalc damage class, and I'm going to scroll up to the top because we're now going to need to capture a couple more attributes. Now, for critical hit calculations, we obviously need our 3 critical hit attributes. We're going to need critical hit chance. Now, this is going to be captured from the source, obviously. So let's declare attribute capture def, and we'll pass in critical hit chance. And we're also going to add a define attribute capture def. So define attribute capture def. And for S, we're passing in U aura attribute set. For P, that's the attribute. That's going to be critical hit chance, not def. We're going to capture critical hit chance from the source, and we're not going to snapshot any of these. Now, in addition to critical hit chance, we need critical hit resistance and critical hit damage. Let's go ahead and just add those macro calls for both of them. We have critical hit resistance and critical hit damage. And we'll make 2 more macro calls here in the constructor for aura damage statics, specifying critical hit resistance. Now, critical hit resistance is going to be on the target, isn't it? And critical hit damage, that should be from the source. And it looks like I have a typo. This should be critical hit damage, not critical hit chance damage. So we'll go ahead and fix that. So it's very important to make sure that we have the right parameters in our capture def. We want to capture from the target or the source, depending on what it is we're calculating. So that's very important. So now that we've defined these, we need to add these attributes to relevant attributes to capture. So I'm going to add 3 copies of this line and change the capture def. First, we're going to have critical hit chance def. Next, we'll have critical hit resistance def. And then we'll have critical hit damage def. Now that we have those 3, we know that we can capture those values. So let's do our critical hit calculation way down here. We want our out execution output down at the bottom. And after we've just ignored a percentage of incoming damage, we can do critical hit calculations. Now we're going to make a float, and I'm going to call this source critical hit chance and initialize it to 0. But then we're going to call execution params dot attempt calculate captured attribute magnitude. So first we pass in, we're going to use damage statics dot critical hit chance def. We need to pass in evaluation parameters. And we need to pass in source critical hit chance, the float, and we'll make sure that it's not negative. So we'll say source critical hit chance equals fmath max, specifying float, and we'll max between source critical hit chance and 0. So we now have source critical hit chance. I'm going to need both the resistance and the damage. So I'm going to copy these 3 lines and paste them, but this is now going to be called target critical hit resistance. And we're going to change this capture depth passed in to critical hit resistance depth. And we're going to change what we pass into this. Our float is going to be the target critical hit resistance. And then we're going to use target critical hit resistance with our max call, passing in the target critical hit resistance and 0. And finally, we need our source critical hit damage. So we're going to change this to source critical hit damage. We're going to change the capture def here to critical hit damage def. And the float passed in will be source critical hit damage. And we're going to change this line to use source critical hit damage. Now we have our 3 captured attribute values. So how are we going to do the math here? Well, we have a critical hit chance, right? This should be a value that has to do with our chance to get a critical hit. I'd like to just treat it like a percentage and see if we got a critical hit. But I'd like it to be affected by critical hit resistance. Critical hit resistance should reduce the critical hit chance. So just like we had a effective armor up here, I'd like to have an effective critical hit chance as well. So I'd like a const float called effective critical hit chance. So what I'd like is to take my source critical hit chance and subtract my critical hit resistance from the target. So target critical hit resistance, like so. And we can even scale this by a factor, like 0.15, for example. And that way, critical hit resistance is not as effective as if we hadn't scaled this. So critical hit resistance will scale down by this factor, and then we'll subtract that from the critical hit chance. So critical hit chance is just a little bit lower. And then we can roll the dice. We can see what a random value between 1 and 100 will be and see if it's less than this effective critical hit chance. So I'm going to make a const bool called b critical hit. And we'll do an fmath rand range between 1 and 100 and see if that's less than our effective critical hit chance. So we'll know if we have a critical hit at this point, and then we can scale our damage. So we're going to take our damage and set it equal to, and I'd like to use the ternary operator again, so we'll say b critical hit question mark. If it is a critical hit, then I'd like to scale my damage by 2. So 2.f times damage. So we're scaling damage by 2. But I'd also like to add my critical hit damage. This is going to be a bonus critical hit damage value. So we're going to say plus source critical hit damage. And then colon damage. So if critical hit is false, then we set damage equal to itself. That's just how I'd like to do it. And we can put a comment here that says critical hit resistance reduces critical hit chance by a certain percentage. And we can say that double damage plus a bonus if critical hit. Okay, so we're scaling target critical hit resistance by 0.15, but we could easily make this data-driven. That was the bonus part of the challenge. So why don't we go ahead and launch the editor, and then we can go ahead and tackle this bonus part of the challenge by adding a curve to our curve table for damage coefficients. So I'm going to go ahead and open up my CT damage calculation coefficients and add a curve and rename the curve to critical hit resistance. And we can specify what this should be. Now, as the levels go up, critical hit resistance, I think, should be less and less effective. So I'm going to start at 0.15 for level 1, but we'll reduce that down to 0.1 for level 10. We'll say 0.8 for level 20, and actually, I should say 0.08 here. And for level 40, we'll say 0.06. So we can see what that curve looks like. Here it is. So just throwing some values out there, but we could change that as we test the game. But now that we have this, we should be able to retrieve this value in our damage execution calculation. So I'm going to save and close and take a look by scrolling up and seeing how we got our curve values for armor penetration and effective armor here. Really, it just has to do with these two lines where we get the real curve, we get our damage calculation coefficients, we find the curve specifying the name of that curve, and then we evaluate that curve at the player level. Now we need to know which player, the source or the target, right? So we'll determine that. Let's copy these two lines. We'll go down here to just before our calculation. We'll paste them. And this is going to be critical hit resistance curve. And we're going to find the curve for critical hit resistance. We're going to call this const float critical hit resistance coefficient. And we're going to evaluate the curve at the target combat interface get player level because it's the resistance, it's the thing getting hit that we're checking the resistance for. And that's going to depend on the level of that character or target. And then we can take critical hit resistance coefficient and replace that magic 0.15 with that value. So the only thing left to do is to see if we can get a critical hit and boost that damage by our critical hit damage. And I've made one mistake, and I can tell because Ryder's telling me that this curve is not being used. And that's because I copied and pasted, so we're still getting the value here from effective armor curve. I need to change that to critical hit resistance curve, and now this should work. So with that, we can play test and see if we can get some critical hits. Okay, so we have our curve. We know that this curve is already set in our data asset for character class info. And we also know that we're initializing the attributes for our enemies using a gameplay effect. Let's go to that gameplay effect and see what it looks like. We're going to go to Blueprints, Ability System, Gameplay Effects, Default Attributes, and we have a GE Attributes test, Secondary Attributes test. And we can make sure that we're using that by going to the Data folder, Character Class Info, and Secondary Attributes is using this test attribute. So we can pump up the values of some of our attributes. Now, really, the only thing we can change here is our critical hit resistance. If we wanted to guarantee a critical hit, we'd have to modify Aura's secondary attributes, right? But let's just see if we can get a critical hit. If I can get my damage doubled in some circumstances, then I'll be happy. So I'm getting a 4. There was a 21, there was an 8. So that 21, I believe, was a critical hit. And it looks like a critical hit is pretty rare. And we're getting a block quite frequently. And I think that's because our block chance is high. Yes, our block chance is set to 100. So I can set that to, say, 12%, and we'll get a lot less blocks. And of course, we could just set that gameplay effect back to the regular one and not the test gameplay effect, so we can see the actual values. But every once in a while, we do get a critical hit, and that is manifested as 21. Now, this is all great. We know that we're sometimes getting blocks and sometimes getting critical hits, which is great. But it would be awesome if we could get some kind of visual feedback and know when we get a block and when we get a critical hit. This is kind of common in games like this, where you'll see some kind of feedback here that shows whether this was a blocked hit, a critical hit, and what have you. The way that I'd like to show that is with our damage number. I'd like to change the color of it if it's a block or a critical hit. And I'd also like to show some kind of message, just like a little flashing message, just like our damage number that pops up and fades away that says block or critical hit, or perhaps even blocked critical hit. The way that we've coded this, we can have both. We can get a block first, cut that damage in half, and then see if we got a critical hit. And if we did, then that halved damage would then be doubled and added to with a critical hit damage bonus. So we have several different scenarios that can occur here, and I'd like visual feedback for that. So the question is how? How do we know whether or not we got a critical hit or a block? Because that's determined here in the exec calc, in the execution calculation. But we're not showing that damage number until we get to post gameplay effect execute. That's in the attribute set.cpp here. So we need a way to know here by the time we're showing that damage number whether or not this damage was critical or blocked or both. We need to know that information. And so in order to get that damage information by the time we're here and post gameplay effect execute, we need a few more skills. And we're going to work on developing those skills in the videos to come so that we can show more feedback when some of these different phenomena occur in our RPG damage calculations. So this is a great milestone. We now have a damage calculation that captures our secondary attributes that are related to combat and changes the outcome of the damage done depending on those. So this is a really great step because it's very common when you're just starting out and making games to implement a very rudimentary form of combat where you have a damage value and you're subtracting it from health, and that's it. Now that we have multiple attributes at play here, damage is a lot more interesting, and it's a lot more tied to power levels of both target and source, right? Of player and enemy. And this is a lot more along the lines of how RPGs behave. So it's actually really interesting. This is one of my most favorite aspects of RPG games is the mathematics behind damage calculations. So excellent job. And we're going to continue our journey developing this RPG in the videos to come. I'll see you in the next video.